Okay, folks, we can get going. Any questions before I get started about anything related to final project logistics or Lab 3 reports or anything of that variety? Okay, so starting next week, I'll ask for you at the beginning of each of your lab sections to turn in a final project status report. And I'll post some information on Canvas about what exactly that includes. The notion is not that this should necessarily take you a whole bunch of time to generate. It's going to be a 1 to 1.5 page document. The idea instead in each of these documents is just going to be to summarize the stuff that you were working on / accomplished in the previous week, your objectives for the coming week, the number of hours that you spent working in the previous week, and if there are any present inhibitors to progress, that would be where to write that down as well so that we can help you get over those progress inhibitors, whether it's access to materials or some bug that's causing you a bunch of trouble. We'll, of course, be talking to you a lot about this as you're working, and so there won't necessarily be any mysteries in this document, but I find that it's very productive to occasionally have folks just sit down and think about, okay, what did we do? What are we going to plan for the coming week? It's very productive. Okay, any comments about any of that? All right, that being the case, I wanted to continue and ideally conclude our discussion today of the Bluetooth stuff that we started last time. Now remember that the conversation that we started last time is how we use this third-party library BT stack, one of the 3 libraries that the Raspberry Pi company ported to the RP2040, in order to turn our Pi Pico W into a Bluetooth server. And I'll just remind you again that there's documentation on the course webpage about how to also implement a client. I'll talk about that if folks want to, but probably most folks want to implement a server. And so let me just very briefly remind you, because we have a bunch to go over today, but I'll very briefly remind you that what we had talked about last time is making a server involves making a database on the Pi Pico. Specifically, we're making an attribute database, and the BT stack library allows for you to describe the database that you want to generate using this text-based description of the server. And last time, what we started doing is walking through this text-based description of a server and reconciling what we had written here against the compiled version of the database that ends up being built by BT stack. And so what we were doing is looking at each of these things, each service declaration and characteristic declaration, and figuring out which attributes does this add to the table and what does each byte in that attribute actually mean. And so last time we had gone through the service declarations and we talked through a couple of these standard characteristics and standard services. And then we had started talking about the really juicy part of this conversation, which is adding your own custom primary service and your own custom characteristics associated with that service. This is the mechanism by which you can turn your Pi Pico W into a highly custom application-specific Bluetooth thing. And we had gotten as far last time as talking about this primary service declaration. So let me just remind you what that looks like, and then I'm going to carry on. We had, when we declare a new service, what we do in our text-based description is first state we'd like to declare a service, and then in the case of the custom service, we have to actually provide the 128-bit, in this case, UUID. It's universal identifier. Now in our case, since this is a custom service, not a standard one, we make one up. Just one that's not already in that big table of valid UUIDs. But we make one up and we say, here's what it is. And what we saw last time is the compiler then goes in and adds a single attribute to our database. And we spent some time last time talking through each of these bytes and each of these attributes. And so let me just remind you that this one contains sort of the same information. So we could walk through this, and this represents the length of this attribute. In this case, it's 0018, which is 24 bytes. It has its access permissions, a handle, which again is just sort of its address in the database. It has a type. In this case, its type is 2800 in hex, which is the universal identifier for the declaration of a primary service. So this is just labeling this as a primary service. And then the whole last part of this is that custom UUID that we declared. And so that's how we tell the system we are about to make a new custom service. Then we go through and actually start adding characteristics to this. And I'm only going to talk through maybe one of these because we've seen this a few times with the standard characteristics, and it's largely repetitive, but there's one important difference that I want to draw your attention to. So the next line of our text-based description of this database is this characteristic description. We say we're declaring a characteristic. Because this is a custom one, we are making up a UUID for this characteristic. Here's its name, right? Just some big string of numbers. And then we specify some of the properties of this characteristic. Let me skip over dynamic for just a moment. Read means that this characteristic is going to be read only. So the client that connects to our device will not be able to write to this characteristic, but it will be able to read this characteristic's value. Notify means that the client will be able to turn on notifications for this characteristic. What notifications mean in a Bluetooth context is that when enabled, if the server changes the value of this characteristic, it will just tell the client without the client having to request an update. So if we turn on notifications, and maybe this particular characteristic, what it in fact represents in the code, I think, if I remember correctly, check in just a moment, is I think it's just an incrementing timer. Every time that timer value changes, the connected client will observe that change without having to request new information, right? So it means just whenever you make a change, blast it out. Dynamic, we didn't see this in any of our previous characteristic declarations. What dynamic means is it's telling BT Stack, this Bluetooth library, it's saying, I would like to handle all read requests and write requests in the event that this characteristic allowed for writing. I would like to handle all of those in my application code. Please don't handle those for me automatically, as you did with the previous standard characteristics. Instead, if the client requests to read this characteristic or to write a characteristic that has write allowed for it, please let me know by way of an emitted event that appears in one of my packet handlers, and I'll take care of it. Okay, so that's what that means. The consequence of this is when we scroll down here and take a look at the attributes that actually get generated as a consequence of this line, what we find is, hold on just a moment, I'm losing my place here. What we find is that this added 3 attributes to our database. The first attribute that it adds, which we can scroll down and look at it just a second, but the first attribute that it adds looks very similar to the ones that we've seen previously. It's the declaration of a characteristic, which includes a length, read-only access properties. It has a handle like everything else. Its type is 2803, which means I'm declaring a characteristic. And then its value is the UUID of the characteristic that we're declaring. In this case, it's that big custom string of numbers. The next attribute that gets added that we'll see here is the value of that actual characteristic. This value includes a length, access permissions. In this case, it's read-only, dynamic with a long UUID. That's what that particular string means there. It has a handle, and it has its UUID. The thing I wanted to point out, the thing that makes this characteristic different from the ones that we've seen previously is because we've labeled it as dynamic, there's nothing in the value field of this characteristic, because whenever the client wants to read this, it's going to get emitted to our application code, and we'll have some variable in our application code that is actually holding the value of this characteristic, and we'll give that back to BT Stack. Here's the value you were looking for. So that is to say, the value for this characteristic doesn't live in this database. It lives in our code, and whenever the client wants it, the Bluetooth library will let our application code know, hey, somebody wants to read this value, and we'll say, oh, sure, here you go. And we get it from one of our variables. Okay. And then the third, because we've specified that this particular characteristic should allow for notifications, a third attribute is also added that represents the client configuration. This is a an additional attribute that holds information about that characteristic, which essentially stores information about whether or not notifications have been turned on for that characteristic. So our application code, every time it changes the value of that variable for this characteristic, it can check this place in the database to see if the client has turned on notifications. In the event that the client has, it'll blast out that change. So that one line, this one line here, added 3 attributes to our database. The characteristic declaration, the characteristic value, and then because we turned on notifications, an additional client characteristic configuration attribute that holds information about the client's configuration of how it's interacting with that particular characteristic, notifications on or off. Okay. And as always, in addition to adding that to the compiled database, the compiler will generate some handy macros that we can use when we're actually tying this database to our application code. We'll see that in just a moment. Okay. And I don't think, so at risk of getting repetitive, let me just, I'll blast through one more. In addition, when we added that characteristic, we also added beneath that characteristic, we said we'd like a characteristic user description for the characteristic that we just added. So this is an additional attribute that will hold some metadata about the attribute above it, about the characteristic above it. This allows for us to give readable names to the characteristic so that when we connect to it with our phone and we see a list of the available characteristics in this database, it'll say something like timer or something like that. It makes it a little bit handier to interact with. And when we add that characteristic to the table, it adds one more attribute to our database down here, which represents the user description. The user description, like the one that we were just looking at, is dynamic, which is to say the attribute that gets added does not have a value field in the database. Instead, whenever the client asks for meta information about this characteristic, BTStack will alert our application code. We'll go retrieve some string that represents the name of that characteristic and offer it back to BTStack. So the standard characteristics that we were looking at previously, these have values in the database, and read requests to these standard characteristics are handled behind the scenes by BTStack for us. Our application, we don't have to write any application code to manage these. These are managed for us. We do write application code to manage read requests and write requests to our custom characteristics in our custom service. Now we could, incidentally, any of those standard characteristics, if we labeled them as dynamic, well then in that case we could tell BTStack, no, I would like to handle read requests and write requests to this particular characteristic in my code, but we needn't. We don't have to do that. We do have to do that in this case for our custom ones. Okay. Any questions about that? So at this point, you know, some of the numbers and the codes and stuff are slightly cryptic, but hopefully it's sort of apparent that fundamentally what's going on here is relatively simple. We are describing a database that we would like to build. That database includes services, and associated with those services there might be characteristics. And then, so we describe the whole thing in this sort of textually, and when we compile, BTStack will generate that compiled version of the database based on our description. And we will tell it if we want to handle read requests and write requests, and that's the next thing that we're going to look at. We have to actually tie, you know, this compiled version of the database to our code. Does that make sense? Okay, so how do we do that? Well, okay, let me first state, how do we actually generate that compiled version? It turns out you add one line to your CMake_lists file. You add this line here, Pico BTStack make GATT header. First argument, as always, is the project name. And then you provide the path to this .gatt text file. That is this file, this text description of the GATT server. You provide the path to that, and as a consequence, when this compiles, if we take a look at all the compiled stuff for this project, we could go into the build folder. There will appear a new folder in our build folder called generated, and within this folder is the compiled server. Okay, so that's how we actually tell it to make this. And now we actually have to implement the logic that allows for the GATT client to interact with this thing, in particular to interact with the dynamic characteristics that we've added to this database. What that suggests is, so how are we actually going to do that? It's a design decision. I think the easiest way to go about this is you start by making a struct in your application code. So you make a struct here that mirrors the layout of the database that you've just generated. Specifically the layout of the custom characteristics that you've added to that database and labeled as dynamic. These are the things that we are going to have to manage from our application code. I think it makes it least error prone to make a struct that mirrors the layout that we've specified in that database. So in particular, the first field of our struct here is an object of type HCI, that's the hardware controller interface. Handle T, handle. We don't actually have to worry about this. This will get automatically provided to us. But then subsequently down here, what you can see is we have a series of fields that map to the characteristics and the characteristic descriptors that we've just added. In particular, for characteristic A, the first of these custom characteristics that we've added, we have a field, a pointer to a character that represents its value. Ultimately, we're going to have just some global character type variable, and we're going to associate its memory address with this pointer. But okay, for now, we're saying we're going to have a pointer to this characteristic's value. We're going to have a short here, a uint16, that represents the configuration. That is a number that holds the value associated with this client configuration attribute. It's that value that's going to hold the information as to whether or not the client has has enabled or disabled notifications. Okay? So it's an additional characteristic, and so we have an additional field to represent it. We have another pointer to a character. It's actually going to be a pointer to a character array that represents the user description. Here too, what we'll find is that we're going to have some global character array, a string that represents the name, the human readable name of this particular characteristic. When we actually tie this struct to our compiler generated database, right, we'll point it to some user description there. Okay, and likewise for every single custom characteristic that we've added. And for this service, we've added 1, 2, 3, 4, 5, 6 characteristics. For each of those characteristics, we also have associated with each of its values and its configurations and its descriptions a uint16 that represents the handle, its address in the database. Okay, so we've added this to the struct as well. It's by way of these handles that we will learn which of these the client is asking to interact with. The client will ask to interact with one of these characteristics to read it or to write it by way of its handle. And so we store the handle of each of those characteristics in this struct as well. And then down here at the bottom, we have some objects of this type, BT stack context callback registration T. This is a data structure that is within the BT stack Bluetooth library that represents callbacks for each of these characteristics, A, B, C, and D. These are the ones with notifications enabled for them. In the event that the client has turned on notifications and we want to alert of a change, we will do so by way of these callback functions, which we will write. We'll look at that in just a moment. Okay, so this is just a struct that contains a bunch of pointers to characters and a handful of uint16s that store or point to the information that we have added to our database. Questions about that? We have not at this point, right now, this is just some struct. We have not actually tied any of this to the compiler-generated database. The two live independently. We have this struct thing over here that's designed to mirror the structure of the database, but we have not actually associated the two yet. That's the next thing that we need to do. Okay. So because we have labeled all of these characteristics as dynamic, what that means is it's our responsibility to write the read callback functions and the write callback functions to each of these characteristics. So when the client says, I would like to read characteristic A, please, it's our responsibility to write the function that actually implements that. So in particular, we're going to write two big functions, a single read callback function that handles read requests to all of our custom characteristics. These callback functions are they take a specific set of arguments that is described in the BT stack documentation. So we'll write our callback function in agreement with the documentation. In particular, these callback functions take as arguments a connection handle, an attribute handle, an attribute offset, a pointer to a character buffer, and a field that represents the size of that character buffer. BT stack will automatically call this callback function for us, and it will call it with the following arguments. So if the client says, I would like to read characteristic A, please, then BT stack will call, once we've got it configured, it will call this function with the connection handle associated with that particular client, the attribute handle of characteristic A, the offset of characteristic A in our database. It'll call it with a pointer to a character buffer, and it will call it with a buffer size. What we then do in this read callback function is we look at these arguments and we ask, okay, which attribute handle has the client asked to read? Has it asked to read characteristic A's handle, or its client configuration handle, or its user description handle? Which of these fields is it actually asking for access to? And then based on the answer to that question, we return, we go access and return by way of this API function here, att read callback handle blob. We go get the characteristics value, get its string length, and we pass back its offset buffer and buffer size. Likewise for characteristic B, likewise for characteristic C, and so forth. The questions about this? So for every dynamic characteristic, we're responsible for handling read requests. When the client asks to read a particular characteristic, it will do so by way of that characteristic's handle. We will then go access the information associated with that characteristic and make it and send it back to BT stack by way of these API function calls, these read callback functions. See a very similar structure for the write callbacks. So for those characteristics for which we have that have write permissions, for which the client can actually write the value of that characteristic, here too, there's a standard set of arguments to these write callbacks. Among them is the attribute handle that the client would like to actually write. We go through, check that attribute handle. We read the data that the client has sent us by way of this buffer, and we write it to that particular attribute, that particular characteristic. Here too, you will notice for some of these attributes, in particular, for the attributes for which we have enabled notifications, we do an additional check. So here, we check, for instance, use characteristic B as an example. We check whether or not the client has enabled notifications for characteristic B. We do so by looking at the characteristic B client configuration field of that big struct. That's where the information that is stored that holds whether or not notifications are enabled or disabled. In the event that notifications are enabled, we schedule the callback B function for execution by BT stack. We add it to a queue to be executed at the next available opportunity. I'll remind you that last time I talked about how under the hood BT stack uses this run loop where it's sort of going through and checking events that it may or may not have to manage. We make this particular callback function one of those events that it should manage the next time that it gets to it. We write these functions, by the way, and that's the next thing that we're going to look at, is what actually happens when we schedule this callback function. Okay, but so just to summarize, for every dynamic characteristic, it is our responsibility to manage read requests and write requests to that characteristic. We do so by writing a read callback function that looks at which characteristic the client would like to read, goes and accesses the information associated with that characteristic, and gives it back to BT stack by way of the BT stack API. And then likewise for read requests. And the one extra step, or for write requests rather, and the one extra step for write requests is we also check whether or not the client has enabled notifications for that characteristic. And we take the appropriate action in the event that it has. Okay. So, but still, we have not actually tied that database to that read callback function, that write callback function, or that struct. What we're going to do now is we're going to generate an initialization function. And what that initialization function is going to do is take all of this application infrastructure that we've built, the struct, the read callback, and the write callback, and we're going to actually point it to the database that the BT stack compiler has generated that we were looking at and reconciling with our text-based description of that database. Okay? So it's in this initialization function that we're going to look at here in just a moment that we tie our custom infrastructure with BT stack's compiled stuff. Okay. So how do we do that? We're going to globally declare an object of type custom service underscore T. This is a BT stack, Bluetooth stack that's used by the RP2040. This is a data structure that it implements. It's one that represents a custom service, as the name suggests, and that's exactly what we are creating, right? So it's this structure that's going to that's going to hold all the information about our custom service. And we're going to declare another object of another BT stack specific data type called ATT service handler. This, as the name suggests, is going to handle ATT requests to our attribute database. What we then do, I mentioned that for these characteristic descriptors, the value field of that struct that holds the characteristic descriptor is a pointer to a character. In particular, it's a pointer to a character array, a string that holds the name of that characteristic. What we then do is just globally declare a collection of strings that represent the names of each of these characteristics for which we have added a characteristic descriptor to our database. So read-only counter, that's the name of characteristic A. When we connect to it with our phone and we look at all the available characteristics, our phone will show us read-only counter once we've tied it to our struct, down here below. And likewise for every one of these characteristics, we're providing them names. And what we'll see in this initialization is those pointers to characters that represent the characteristic descriptor. Initialization will involve setting that pointer to the address of the appropriate string associated with that characteristic. Okay. So within our initialization function, we pass as an argument to this initialization function a series of pointers with names that kind of suggest how we're going to use them. We pass it a pointer to a character called A pointer, a pointer to a character called B pointer, C, D, E, and F. And then we create a local object of type custom service underscore T, right? And we associate this local object that we've called instance with the address of that globally declared service object that we just created, okay? So this is a handy way of us that we can interact with that global object that we've just created here, right? So in any case, what we then go through and do is we set the values of each of these fields of this global service object, this struct that we just created. In particular, we go to the characteristic A value of that service object struct. Remember, this service object struct, this is just this guy here, right? That's the custom struct that we just created. During initialization, we created a global object of that type. Right here, this is our custom service. And now we're going through and setting each of the fields. And in particular, we're setting the A value field, which you will recall is a pointer to a character, to whatever argument that we've passed in here. In practice, what that's going to point to is just some global character variable. Likewise for B, C, D, E, and F, right? We're passing in the addresses of some global variables, and then we are specifying that each of the fields for these characteristic values, pointers to characters, should point to these global variables that we can manage in our application code. Likewise, each of these characteristics has user descriptions. You'll remember that these two are just pointers to characters. Here, we just give each of these fields the address of those strings that we were looking at. So now the characteristic A user description field of this custom service implementation, a pointer to a character, it now points to this string. And here, it's in this big ugly mess. This is where we actually tie our stuff to the compiled stuff. Remember how the compiler generated those nice handy macros that represented the handles for each of these characteristics, the start handles and the end handles and so forth? Here, we associate the A handle field of our custom service struct. We assign that the compiler generated macro that represents the handle of characteristic A in that compiled database. So that has associated this custom struct that we just made with that compiled database. Likewise for the client configuration handle and the user description handle, right? And then this repeats for each of the characteristics that we've just added. So now this custom struct that we've just created, right, that live totally separately from the compiled database, now the two are connected. And they're connected specifically by way of the handles. I'll just remind you that whenever the client makes a read request or a write request to a characteristic, it does so by way of its handle. And so now, when it asks for a handle, we know which characteristic it's talking about. And then up here, we've associated a pointer to a value for that characteristic or a user description for that characteristic. So when that read callback function gets called, we go, oh, okay, I know exactly which characteristic you're talking about. I have a pointer to the value that you're looking for. Let me go get it. And then I'll use one of these API functions to just give it back to you. There's a couple other capabilities that are really handy to implement here. It will be the case that for some of these characteristics, we would like for our application code to be able to update their value on its own, but to do so in a way that is that in the event that, for instance, notifications have been enabled for that characteristic, our application code knows that it should send a notification that has just changed a value, right? So, for instance, characteristic A, we labeled that as being, you can turn on notifications for that, right? So this set characteristic A value, which takes a value as an argument, this is a function that we can use in our application code to modify the value of that characteristic. When we do so, what do? Service object is that global object of the type, the custom struct type that we just created, right? So here, we make a local pointer to that object so that we can, access its fields and so forth. We go through and we adjust the characteristic A value field of that object to whatever value that we've just passed in. Remember that arrow? If you pass a pointer to a struct, the arrow dereferences the field, right? So we dereference the characteristic A value field and change its value to whatever we just told it to change to. Then we go check the characteristic A client configuration field to see whether the client has turned on notifications for that particular characteristic. In the event that it has, we set the callback function for characteristic A to be the characteristic A callback function. We're going to look at that in just a moment. That's right here, another function that we write. We set its context to be our service object type. And then this API function call, this is something from BT stack, ATT server register can send now callback. This adds this callback function to that execution loop that's under the hood for BT stack. So it says, hey, when you get to it, when you're ready, please execute this function. We're scheduling it. What is the function that we're actually scheduling? All that this function does is it calls another BT stack API function, ATT server notify, as the name probably suggests. This is a notification. We pass in the connection handle. We pass in the handle of the characteristic for which we're providing a notification. In this case, it's characteristic A. We pass in characteristic A's new value, and we pass in the length in bytes of that value. This function, BT stack, then on our behalf, when it gets to it, it will execute this function, and as a consequence, there will be an actual radio transmission back to the client that lets it know, hey, the characteristic with this handle, it's this long, its value field, it's just changed, and it's changed to this. Questions? Okay. So to actually instantiate the server, right, so here's like main, for instance. What does this actually look like? Well, we declare some global character arrays up there. We'll see how those are used in just a moment. And then within main, sort of as usual, we initialize standard I/O. This particular example, this document uses the VGA, so we initialize the VGA. We initialize the CYW43 driver by way of this arch init function. Which, by the way, if you care, I mentioned it's important when you're trying to interact with a third-party library, when you want to go use it, it's a good idea to pause for a moment and reflect, what am I trying to do with this? Am I trying to improve this library or make a contribution to it? In which case I should develop an extraordinarily deep understanding for how it works. Or am I instead trying to use it in my application code? In which case I need to get a very deep understanding for how I design for compatibility with it. What resources does it consume that I should be careful not to consume in my application code? And how do I safely interact with it? When I started trying to figure out BT stack, I did not pause and reflect. And if you want to see the carnage from that, this is my effort to try to understand that single function. And this was not... I'll see you guys later.